Homework 16, Exponential and Logarithmic Equations, Video 7. Logarithmic equations, logs equals logs. I had suggested more than once in this series of videos that it was probably going to be 8 videos. It's going to be 7. So this is the last video in this series. This is the last video over the homework that would be covered on the final exam. This is the last video of the class. It's kind of a bittersweet moment. But in the previous types of logarithmic equations, we had logs on one side and a number on the other. But sometimes you don't have that number on the other side, you just got more logs. If you have logs on both sides, the approach is kind of the same as before, except the second step. You still condense, but now there's the possibility of condensing one or both sides. But your objective is to get one log on each side. One log equals one log. If you start there, great, skip to step 2. If you get one log equal to one log, then the second move is easy, you cancel the logs. But it's important to state that you do not cancel the logs until there is only one log on each side. So for example, on this equation, log base 3 of x plus 1 minus log base 3 of x minus 1 equals 2 times log base 3 of 5. Canceling the logs now would be catastrophic. Number 1, it would be wrong. Number 2, all the x's would cancel. You cannot cancel the logs until there is one log on each side. Log of something equals to log of something. So your first move is to condense until you get one log on both sides. So let's do that. On the left, we have a subtraction problem of 2 logs, the difference of 2 logs. That's the result of the quotient rule, so we can work the quotient rule backwards. The difference of 2 logs can be condensed into one log of a fraction. The positive logs argument goes on top. The negative logs argument goes on bottom. Now on the right side, we got a different condensing issue. There is only one log, but it currently has a number in front. And we know how to deal with the power rule that says put that back in as a power. So the 2 goes in as a power on the 5 and make it log base 3 of 5 squared. But once you get one log equal to one log, and not until then, you can cancel the logs. Again, only if there is one log on each side. Not multiple logs, no numbers in front. Log equals log is when you cancel. So if we cancel, we're left with x plus 1 on top of x minus 1. And on the right side, we're left with 5 squared. Let's go ahead and call that 25. And then solve. Now you know the quotient rule brings fractions in, and you may be solving an equation with a fraction. Don't let that discourage you. All you have to do to solve an equation with a fraction is to clear out the fractions. Well, that's not all you have to do, but it's a good first move. And remember, a fraction is just a division problem. So if I want to cancel the denominator of a fraction, I can just multiply both sides of the equation by x minus 1. I was emphasizing of the equation because on previous tests, I saw people multiplying on both sides when there was not a both sides of something to multiply on just to kill a fraction. Like if they had something like f of x equals x plus 1 over x minus 3, out of nowhere they multiply by x minus 3. We're not solving an equation. I can't, unless if I do that, I have to put 1 over here and I don't want to mess with this side. So the time that you can kill fractions is when you're solving an equation and there's a fraction on one or both sides. But let's continue. If I multiply both sides of the equation by x minus 1, the x minus 1's cancel. That leaves x plus 1 on the left and a distributive property waiting to happen on the right. 25x minus 25. This is a simple linear equation. Granted, I've got x's on both sides, so I need to get rid of one of them. I always recommend subtracting the smaller of the 2 because it will leave the resulting x positive. So we get 1 equals 24x minus 25. And I'm just going to expedite this. Add 25 to both sides. It'll cancel this one and give you a 26. And then divide both sides by 24. You get x equals 26 over 24. Let's go ahead and reduce that to 13 over 12. And before we circle it and say that's my answer, we still have to check. We still have to make sure that that number does not create any negative arguments. So even though it's a fraction, we got to check it. Putting it here is not a problem. That fraction's positive, adding 1 to it's going to keep it positive. But what about putting the 13/12 here? What is 13/12 minus 1? Well, it's a subtraction problem involving fractions, which means we need a common denominator. I can rewrite 1 as anything by putting any number over itself. So 1 is the same as 12/12, and when you subtract fractions, you get and keep a common denominator, then subtract the numerators. 13 minus 12 is 1. It's barely positive, but that's good enough. So 13/12 does not cause any of the arguments to become negative, so I keep it. I have seen problems where you have one answer and throw it away, so don't just assume that because it's the only solution we got, it must be good. I don't think I'm going to do another example of solving logarithmic equations with logs equal to logs, because it's going to run the same course, just maybe some subtle differences. Condense both sides as necessary. Once you've done that, cancel the logs, finish solving, whatever that entails. Make sure your answer doesn't create negative arguments.